Right, exponential equation. Example, we're going to have these all to three significant figures. So it would be a good reminder of how to do significant figures. 2 to the power of x is equal to 6. So 2 to what power equals 6?
No, I don't know.
Any suggestions on how I'm going to approach this?
The log of base 2 to the 6 equals x. No. I'm not talking about. Yes, maybe?
That's one way. Yep, what's another way we can do it? Okay, I'm going to show you the other way. Bless you. Introduce the log on both sides. Okay, so it's an equation. I can do the same thing to both sides, provided I do that. Okay, so you can add, you can subtract things, do whatever you want, as long as it's the same, it will still be equal. So, what do I do next? Thinking back to your log laws. Something to do with the x power. Good. Alright, so bring the x power down. So x times log e of 2 is equal to log e of 6. Okay, so again, I can write that as ln for natural log. So x is now log base e of 6 over log base e of 2. Okay, solving for x. 3 significant figures.
2.58.
Right, so the first significant figure is that 2, the second significant figure is the 5, and you need to use the fourth one to round the third significant figure, just like your decimal places. So again, you should check that. So 2 to the power of something between 2 and 3 will certainly give me 6. Right, so seems reasonable there. Sorry? 2.58, what's the next digit?
Yeah.
Yep. Alright, next one. 3 to the x is 20. So between what two integers should x be? 2 and 3. 3 squared 9 and 3 to the power 3 27. So I'm expecting 2 point something or other. Alright, as my answer. So that's the things you should be thinking about if you want to perform well. You'll be able to look at your answer and see whether that makes sense in context to the question. Alright, so introduce log to both sides. Or if you really wanted to, you could change your exponent to a log and then do the change of base, etc., etc. Right, we might just do that next to show that we get the same answer. Then your log law, when you have the power, bring it down. And then solve. So when I change the base, if I were to write it as a logarithm and then change the base, I should be getting that at the end. Alright, 3 significant figures.
2.73.
2.73, do we agree? Right, certainly seems reasonable. Make sure your rounding is correct. Alright, or the alternate way is 3 to the power of x is 20. Okay, the log, so that stays down. 3 to the 20 is equal to x. Right, however, you will need to go and change the base so that you can evaluate that. So x is going to be the natural log of the number at the end over the natural log of the original base, which is what I've got there already. Okay, so that's an alternate way you can do it. Alright, 3 to the power of x plus 1 is equal to 8. So the power must be between which two integer values? Not x, the power itself.
1 and 2.
So I'm expecting something between 0 and 1 because I'm adding 1 to it. Okay, so that's sort of technique to look at. Once you understand the process, you can start taking a couple of lines, reduce your working bits. You can go from here to here to here if you wish. However, you need to understand the work first. Right, so I'll keep doing it like that. The natural log of 3 power of x plus 1 is equal to the natural log of 8. You introduce the same thing to both sides. Use your log law, so x plus 1, natural log of 3 is equal to the natural log of 8. So x plus 1 is the natural log of 8 over the natural log of 3. X is going to be the natural log of 8 over the natural log of 3, take away 1. Right, so don't round until your final answer. Right. Do not round. If you have to round early, if you absolutely have to, make sure you have at least 2 decimals or significant figures before you do your final rounding. Okay? Sorry? 0.893. Alright, so does everyone understand the difference between this is 3 significant figures, or the similarity, sorry. This is 3 significant figures. That is also 3 significant figures. Because that 0 is not considered significant. Unless there was a non-zero in front of it. And that was done way back in the first topic this year. Right, last one. Four to the power of 2n, take away 1 is, so 27. Okay, so the power has to be between what?
1 and 2.
Okay, 4 to the power of 1 is 4, and 4 squared 16, so it has to be somewhere between those two. Alright, introduce the logs. Okay, in the log law, you can bring down the power. Okay, make sure you put it in a bracket because it's the whole thing multiplied by the natural log of 4. Not 2n take away the natural log of 4. And careful with your final working. Okay, so of course your n is going to be different because in the power itself it's going to be 2 times your answer, take away 1.
1.20.
1.20. Okay, because you've had non-zero numbers, that's first significant. Second significant, because non-zero numbers, that makes any zeros after that significant. Okay, so you've got to remember that. Alright, so you've got 2 times that, which is 2.4. Take away 1 would be 1.4. Okay, so that certainly makes sense in terms of what I need. Right, 4.6. Okay, so this part here, just make sure everyone got that. That goes on the numerator of your main fraction, or you do that calculation first and then you divide your answer by 2. Any questions?